Hey everyone, welcome to Portland ReactJS tonight, and I'm really glad to be here and have an opportunity to talk with you guys about React and functional programming and Recompose. I'm not terribly creative when it comes to the titles, or at least this one. So if you've done any functional programming, you've probably come across Learn You a Haskell. So tonight I decided to go with Learn You a Recompose. You can actually get to these slides if you want to follow along at slides.com/Kyle Shevlin /learn-u-recompose. Um, Otherwise, you can just follow along with me. That's kind of the point, right? All right. I also want to do. It's also got a side of functional programming. One of the things I find really important about teaching people anything is making sure everyone's on the same page. Recompose is a library that heavily uses higher order components, which is a paradigm in React of composing components, and it kind of requires some base understanding of functional programming. How many of you have done any functional programming? Yes, lots of hands up. Awesome. Um, Before we get into that, though, let me tell you a little bit about myself. As I said, my name is Kyle Shevlin. I'm a senior software engineer at Fastly. We make the internet faster. Our primary application is a CDN. You're using us every day if you're on Twitter without realizing it. I love JavaScript. I hate semicolons, mostly in my JavaScript. And you can follow me on Twitter at Kyle Shevlin. And that's my wife. And this was a Christmas party. She was eating me with a Sherlock Holmes hat. That was fun. Good stuff. All right. And what we're going to cover today, we are going to cover Recompose. You can check out this library. You can get it at the link on the slide. I recommend taking a look at it. It's got really decent documentation. And it's made by Andrew Clark of Facebook, also known as ACD Lite. Then we're going to cover some basic functional programming, specifically things as functions as first-class citizens, higher order functions, currying and partial application, and composition. If you understand all these concepts, you'll be able to not only use Recompose, but you'll be able to build your own higher order components very easily to work with Recompose. We're going to cover how to write our own higher order components, and we're going to cover how to use Recompose, of course, because that would be kind of lame if I just did functional programming and I bogarted the whole talk and not talk about React. So you'd be surprised. And we're going to do some demos. I'm going to try to do some live coding. So my hands are already getting a little shaky and cold and nervous from it, but we'll make it work. Now, functional programming for half of you seem like it already know a little bit about this, but it's a type of programming that heavily uses functions. In fact, in some languages, it's literally the only way to generate basically anything, any sort of state, any kind of variable, any kind of expression, anything you're trying to do. And in JavaScript, we actually have this wonderful language that allows us to both do object-oriented to some degree programming with classes and extending them and prototypes. But we also have this opportunity to do composition and use lots of functions and small testable, that's the big thing, small testable functions to build up our applications. You probably don't need to go whole hog on it, but we're going to learn just enough functional programming to be dangerous, or the minimum amount of functional programming you need to know to be dangerous to yourself and your coworkers. I mean this kind of literally. The other day, I made a pull request into the code base, and I had one function that returned another function, and it really kind of confused some people. And I realized, whoa, I got to back up a little bit, and I have to explain something. So be careful with this. Use this knowledge at your own risk. But the first thing you need to know about JavaScript is that JavaScript is a language where functions are first-class citizens. And what this means is that functions can be passed anywhere. They can be passed as they can be saved as a variable, and they can also be passed in as an argument to a function. And this is actually pretty awesome. It means you don't have to save out the value that's evaluated from a function. You can just pass the function itself into another function and get that value at runtime. And that's really actually quite impressive. Is this big enough for everyone to see? I should have asked beforehand. Bump it up. How's that? Hey, yay. All right. So back to functions as first-class citizens, right? We're not going to miss a beat at all. But we already talked about that, right? That's the fact that functions can be passed in as arguments, they can be saved as variables. It's very nice. Which leads us to higher order functions. This isn't really going to work. I used up the whole screen. I'm so sorry, folks. A higher order function does one of two things. It takes a function as an argument, and or it can return a function. And this is where the real power of like functional programming, especially in JavaScript, comes in, is the ability to take a function and return another function. And if you can see on this, I have a function called emoji logs. It's going to take in an emoji, and it's going to return another function that's expecting arguments as strings, and it's just going to join those together with spaces and return it out with whatever log you wanted. So the first one is the cat log that I made. I passed in the little cat emoji. The second one is a dog log, and it has the little puppy emoji. And then the last one's a log because you know you need that. So you know I passed in my cats, and I get Krios and Tally. They're named after Mass Effect characters. If anyone's a video game nerd here. Then the dog log, I was like, why don't I have one of these yet? I was really upset about that. And then the log, Douglas firs are really cool. But this is a very simple and possibly annoying example of how we can return functions and how that's a higher order function in JavaScript. Which leads us directly into currying and partial application. What you just saw was currying and partial application. Now, don't get nervous about this term currying if you haven't seen it before. Currying is a technique of refactoring a function that normally accepts multiple arguments into one that accepts them one at a time. A curried function will also continue to return a unary function. Unary is a fancy word for one argument for each argument until the final one is provided, and then the function is evaluated. And these arguments provided to a curried function are said to be partially applied, while the function awaits its final argument. And you should understand this if you understand closure. The first arguments that you pass in are being stored as in closure for the final function that takes the last argument and evaluates and returns what you need out of this. So what we saw on the previous slide was we can see that the emoji is held in closure for the return function below. And so the canonical example of currying is the add function. Most of the time, if you were going to write an add function for you, your friends, or whatever, you write it so that it takes two parameters, right? It takes an x and a y, and it returns x plus y. But a curried version will take an x and return you a function that's expecting a y. And then when it finally gets the y, it'll evaluate and give you that answer. So as you can see here, I have add, it takes an x, and then it takes a y, and then it returns x plus y. And we might do silly things like add to. Jason and I were actually joking about this before the talk because this is how everyone learns currying. But you have add to, and then if you wanted to get to the value 8, you could have like an add 5 and add 3, right? And what I wanted to show, and I have a little typo there, but what I wanted to show is specifically here, because they're higher order functions, we can pass a partially applied function into this. So add 2 plus 8 will give us 10, right? Everyone clear on currying and partial application? I'm seeing some nods, we're seeing some good, which leads us to composition. This is where the real bread and butter of functional programming is. This is where if you get to this stage where you understand composition, you've known just enough to like really refactor a lot of the code in your code bases, even if you're not using full FP. It really gives you opportunities to dry up areas of your code, especially we were talking about building up like classes through composition, or if you have two things in your application that are very similar but might have one or two things different, composition might be a much nicer way of creating those different objects instead of making a function that takes like 3, 4, 5 parameters and spits out a different object for you. So what composition is how many of you like remember like I'm gonna guess it's about algebra 2 in high school or something like that. You would have learned about f of x. And composition is the idea of two functions, g of x, and passing the evaluated value from g of x into function f. And you can see that right here. This takes the form of f g of x, where f and g are both functions. But nesting functions in JavaScript can be really ugly, and I decided to give you an ugly example. I have the function scream here, which takes a string and uppercases it. I have exclaim, which adds an exclamation point, and repeat, which does it twice. And then I ended up with a function through nesting called warn Steve. I don't know why, but I chose Steve through all my examples here. So if you're Steve in here tonight, I'm going to yell at you a lot. No. So you can see like we nest scream inside of exclaim, inside of repeat, and we end up with Steve, the world is coming to an end. Steve, the world is coming to an end. But that could be really long, especially if you had function names that were longer than a few letters, that were longer than one word, right? If you're doing clean code and you're writing function names that are descriptive of what you're doing, we're all doing clean code, right? I'm just kidding. But if you are, right? If you're doing clean code, right, you might have something that's incredibly long and just really hard to read. So this is where composition comes in. What if instead of nesting, excuse me, what if instead of nesting functions, we use currying and partial application instead? So currying means we change a function except its arguments one at a time. And we know that partial application will store that data inside a closure while we're waiting for the function to evaluate. So what composition allows us to do is if we can make a new function that's just waiting for its last argument. So what we have up here is I wrote a really quick compose. If you were to use compose out of like low-fp or Ramda or anything like that, this is basically what it is. It's a function that takes any number of functions and then waits for a value. And then if you didn't know this, reduce write is a method on arrays. It's just the opposite of reduce, obviously. And then I really spelled it out, clean code. I said, we're going to take the accumulated value and the current function, and we're going to return that function with accumulated value passed into it. And then the starting value is just our value, right? And so what we get is, I decided to call this with gusto, right? We're going to compose, scream, exclaim, and repeat. And yes, I said those in that order. With compose, you need to think of things as right to left or bottom to top. There is a equivalent method on some functional programming libraries called pipe or flow, if you've used Lodash or Ramda. But compose is typically the more mathematical way to think about it. So just so you know, you want to think from the bottom up. And so in this case, scream, that gets passed to exclaim, gets passed to repeat, and we end up with the same thing. Warn Steve with gusto, Steve, the world is coming to an end, and we yell at Steve one more time. Steve's really going to not like me by the end of this. So that's my intro to FP, and we'll get into higher order components now. So what is a higher order component? I'm going to hope everyone knows it, but I want a show of hands. Who knows what a higher order component is? Okay, a good portion of the room. That's awesome. So a higher order component is just a function that takes a component as one of its arguments. It could take any number of arguments. If you're using Redux, you're using higher order components that take more than one argument, and it returns a new component. A basic hock. I'm sorry, for whatever reason, syntax highlighting kind of broke in slides. I don't think it likes JSX very much. But I decided to write an identity hock component. If you understand the identity function, it's literally a function that takes what you pass in and gives it right back to you. But this is essentially what an identity hock would be. It takes a base component, which then returns a function that takes its props and then returns you a base component. We're just spreading the props out, right? You might recognize this signature here, right? Props and a component. That's a stateless functional component, right? That's that function signature there. So we have our first user here. User takes a name and an age, and we just have a basic bit of markup there. This is also a user. This is now a new component. We just use our higher order component. We pass it the base component, and then it's going to wait for its props and give you out the components markup. And so you can see React render. We have the original one. Yes, I'm 32. And then also user, you get the same thing out. Not very useful, but that is a way to start understanding the pattern of writing your own higher order components. You want to take a base component and you want to apply some stuff to it, and then you'll return a new component. So why use higher order components? Well, one of the ways it really helps out is drawing up code. Now I know render callbacks are like all the rage these days, but higher order components still give us a lot of really nice ways of drawing up code, especially if you're passing around like the same set of data throughout your application, or as we'll get to see in Recompose, you'll see that you'll be able to like compose different state by having these tiny, very testable functions all throughout your application. So how many of you have had components that use something like is loading, or uses is active, or is hidden? Like imagine instead of having to write that for every component in your application that needs it, you just wrote it once, and then you composed and wrapped your base component with it, and it just had that state in the same shape. You'd really dry up some code throughout your application, and I think that's a win. You have to get your team on board, but it's a win. Um, this also separates logic and view concerns to some degree, because what we're really going to see in this pattern is that we're going to pass mostly stateless functional components into these higher order components. And our whole app then becomes these really testable, snapshotable components that are just rendering based on their props. And then we add all the extra logic on top via the higher order component. And then they're really composable. So, I mean, that's the whole point of this. We gain by being able to take small things and build bigger things with them. That's the real win of using Recompose. So, hey, we're finally at the Recompose API. I hope you're still with me. So, I've already mentioned you're working with stateless functional components. What might be the first thing you need to make a stateless functional component more useful? State. Good job. The guy from Magic Leap is paying attention. I can see him. All right, so the very first higher order component out of the the Recompose library that we're going to cover is the with state higher order component. If you want to follow along, I made a repo. This is my local copy, but I will pull it up real quick. If you want to see like some examples of this as I go through it, you can go to kyleshevlin.github. I can type io.com/recompose demos. And you can follow along with some of the things I'm going to be talking about. So if you want to pull that up, that's fine. I'll try and bump that up for you. kyleshevlin.github.io/recompose demo. And you can, you'll see these just are toggleable sections. You can get through them. Anyways, so with state, I added the type signatures for you, so you can actually see these in the docs at Recompose on GitHub. But this gives you a good idea of like what the arguments you're going to pass in and what it's expecting out. So with state expects a state name, which is just a string. This is what you would actually put in your state object in your constructor, or if you're using transform class properties, you would just write state equals this object. But that's a state name, so it would be like is toggled :false, right? And this, the set toggle, the second one, the state updater name, that is the actual function name you're going to use to update that state with, just this state. So if we look at this learn new recompose, I kind of wrote it out. And I can pull up the code really quick. Oh my gosh, so small. So we have ourselves like a status list, a status, a tooltip, and what we're really getting out of this is right here. With toggle, this is a higher order component that's going to check whether toggled is on, and it's going to take a function toggle, and the starting value is false. And what you see is we can use this toggle in multiple components, and it gets passed down as props. The thing to know about higher order components is you no longer have state. Your state gets passed down as props. It's maintained in the closure of the higher order component, but it's passed down to the base component as props. That is one thing to get used to. But we pass down the toggled on Boolean and the toggle function as props to our various components, status here and tooltip. And we can do things like, in this case, on the on click of the status, we're just going to flip the state. Or we can pass in a value that we just want the state to be. So on the tooltip, when we mouse in, we'll see toggle just get set to true. And when we mouse out, we'll see toggle set to false. And if you go to the example here, you can see that. If I click the active button, that's toggled on, and I click it, it flips it. That was that x equals not x. And then if I hover over Kyle, he's a cool dude. I'm going to bump this up. At least I think I'm kind of cool. So yeah, that's with state. That's the very basic thing to get state into your stateless functional components, and we're going to build upon that. So the next one is with handlers, because it's not really nice to just have to pass direct values into it. We might want to actually have a function or a couple of functions or methods that handle our state changes. So with handlers allows us to do this by creating our own methods. And it's just an object you could see. It is expecting this state updater function that we had from with state. So we're going to use this in conjunction. We're going to use these, we're going to compose these together. So it takes the toggle from props and it returns a new function. This is the function that would actually get used on the event. So if you have an event you need to listen to, you would pass the event into this. And then on the, in this case, we're just going to set the toggle or toggle the toggle. That's a great phrase right there. So going back, we have the same example. Oh, we have the same example with handlers, but it's just a little different. Now we're using the actual with handlers example. You can see I've changed it now to actually, and you can see where I passed in the event. I did that so you could see where that would go. Yeah, it's the same functionality though, but the way we got that is we composed, you can see that here, we composed our with state and our with handlers. We're starting to learn how to actually combine some of these things. And then for those of you, how many of you love Redux? I love Redux. It's great. Don't overuse it. Use it in the right places. Let's not start a war here. But if you really like the use of reducers, you're going to really like the next one. Maybe you don't want to write out all these handler methods, but you would rather write something you really know really well. So with reducer allows us to handle our state with a Redux-like reducer pattern. And what we end up passing is rather than passing in a state updater with a particular name, we're just going to pass dispatch. This way it even looks the same. And then when we get into the code with reducer example, you're going to see that we actually in the handlers will call dispatch. So with reducer replaces with state and becomes our new way of managing state. And it takes all the same arguments except the third one, which is our reducer. And then we have with handlers here that takes that state updater name, in this case dispatch, and we're just going to dispatch the action. And you all know you could make action creators out of this. You could have action creators throughout your application and then pass them into these mini state reducers too. We were talking earlier today about how like you can do functional set state. Well, you could use those same functions that you need not only for set state, but you could use them here as well. And you could use them in your actual Redux reducers if you needed to. So hey, more code reuse. That's awesome. Which leads us to what's the next thing you want in your stateless functional components? You would want lifecycle methods, right? You want to get into getting to use should component update, component did mount, component will unmount, all those things. You can do that through a higher order component. How many times have you had components across your app that have the very same component did mount fetching data? You can rewrite this as a higher order component with lifecycle. You could curry it, because now you know, you could curry it to expect a different endpoint, and then now you have a new function you can pass around your app and compose with to change the endpoints you're reaching for the components in your app, if you wanted to do it this way. But lifecycle is just a higher order component that I did not update that text. Good job, Kyle. I'll do it from the slide. Lifecycle is a higher order component that adds all the lifecycle methods to a component except for render. That makes sense, right? Because we're handing render off to our stateless functional component. And I even used a with data example. I've built a lot of small apps for side projects where having something like Redux is a little overkill. And all I really want to do is hit one endpoint and I want to pass it to a bunch of different components and maybe massage the data along the way. And you can write something like this. Lifecycle, when the component mounts, we're going to fetch data and we're going to set state with that data. Now, I'm setting state with that data. What is that data to my stateless functional component? If you're paying attention, you got props, right? Good job. How many of you have argued about whether you should use pure component or not? Oh man, not many. Oh, I've definitely been in some flame wars around it. You want to get that really easy in Recompose? You just wrap it in pure, done, boom. All it does is take your component and automatically changes it to a pure component. So do you know what pure components are? They're one that already implements the should component update method and specifically does a shallow check on the props object coming in. But it's a way to only update functions when their props change. Um, it's not perfect. There's read up about it. Please don't take me on my word on that. But it can increase the performance of your application. And then the other thing you might want to do with higher order components is you might want to massage the props coming in. So you might be getting one set of props, but you know you actually want to override some of them, or you might want to manipulate them in some way. And so there are two. There's two. There's actually a bunch more, but these are like the first ones you'll use. And they're very similar. You have map props. Map props is a higher order component that takes allows you to massage the owner props coming in. And the key to know about map props is that it's going to blow away any prop you don't end up passing down. So if you have an object of this many keys and you end up only returning 2 keys in the next object, you're going to lose all the other keys. You need to know this when you're using map props. It's going to blow it away. So in this case, like maybe I have a user component that expects a name, and I told you all my examples were Steve. So in this case, if I use map props and the name is always Steve, no matter what I pass into a user prop, it'll always come out as Steve. This could be really great. Like I'm a part of a forum for Destiny, the video game, and one year for April Fool's Day, they turned the whole forum into everyone had Taylor Swift avatars. You could actually do something like this really easy, where you would override every prop in the application with like the avatar URL you want or the name property you want. So if you've got an April Fool's joke coming up for your company, Recompose. Um, Jason's that's his next lesson coming out, right? Like it's gonna be, here's how to make a React Native app that doesn't do what your customers want it to do. Um, so the next one is with props. It's very similar, but this one is a little more manageable because it'll just merge. It does basically object.assign. You guys know that method, so it's gonna merge objects that come in. So in this case, merge Steve and keep the rest. Maybe you pass in things like age or his location. I don't know where Steve lives. I'm just saying, like, but this way we only override the props we intend. And I decided in my little thing here, I combined them. And what you're going to see is if I pull it over here into the code. So I made a component called question and answer. And the first question down here just takes what is the meaning of life? I said to be happy. And what do we see over here? We see to be happy. The second one is 42, because we all know the meaning of the universe is 42. Who cares about the question, right? So question, what is the meaning of life? It does not matter what answer you give, right? Because I'm overriding it with map props, which I pass in the question. I just let it go as is. And then I'm changing the answer to 42. Does that make sense? And so we see over here, what is the meaning of life? Answer 42. And then the last one I decided is with props, you can override whatever you want. In this case, I decided to override the question, but it allows everything else to pass through without me having to do it explicitly. So the question is, how is Kyle doing? But you see here in the component, I'm actually passing what is the meaning of life? And the answer is, he is doing fine, hopefully. And so what you see, it's not what is the meaning of life, it's how is Kyle doing? And as I said, hopefully. So these are really useful for you. But the big thing that really sold Recompose for me and made it interesting to me was this idea of being able to build branches. Now, we all build applications that have conditionals, and we've all probably built an application that if this state render this, if this state render that. Recompose has a really nice composable higher order component called branch that allows us to do that. I'll go back to my slides if you don't mind. Branch is a higher order component that allows you to conditionally choose between 2 higher order components. Those of you familiar with functional programming, this is a left and a right, right? You have a left path and you have a right path. And the way this works is the branch higher order component expects a predicate. A predicate is any function that evaluates to a Boolean. So in this case, maybe my component will have a prop called isLoading, and we're just going to pass that because it's a Boolean. And so we pass it in here. If isLoading is true, it'll render the first one, in this case, component left. And if it's false, it'll render the third one. And you might see in this comment here, clearly my screen's not big enough, but The third one, you don't even have to supply. The way branch works, it implicitly will take the component you pass in as the last argument, and it'll pass it in as the third one. And this goes hand in hand with render component, excuse me. Render component does exactly what it says. It takes a component and it actually does a type lift. It's a monad of sorts. It type lifts a stateless functional component into a higher order component so that you can continue to use and compose it. And so when we combine those things together, we're going to get to the section of this where I attempt to do some live coding. I gave you a nice slide there. How many are familiar with this? I made sure to find one that was cool with the code of conduct. You know, like I didn't want to find the real one, but we're going to try and do this live. Okay, so the thing that sold me on Recompose was the ability to make a component that I could pass around my app that no matter where I needed to load stuff, it would show a spinner. And I'm going to give this a shot. Just so you know, I did kind of cheat a little bit. Let's see, we will do it live example. I have it all there. I have all the notes there in case I fail really, really badly. But what we're going to do is we're going to take, we're going to use branch and lifecycle and render component, and we're going to create a component that will have an is loading state, and we're going to take, we're going to have a base component and pass it in, and then we're going to wait for the data to load, and we'll see a spinner, and we'll see the branch work. And you've probably done this all the time in your app, but now you'll have a small little function that you can just pass around your app and do this with. Okay, so the first thing we need is we need an endpoint to hit, and I thought a good one to hit was the Google API. So maybe I'll try and cheat a little less. But API to, I talk a lot while I type. Do any of you do that? I should do live streaming. Yeah, maybe make some money, some of that Patreon money, right? Like, um, any of you fans of South Park? Got to get me some of that internet money, right? Like, do you guys know? All right. So the first higher order component we're going to build is a lifecycle component. We're going to split up the lifecycle. You can do this all as one, but I wanted to show you composability even further. And I'm going to just do the state with this one. So we're going to call it with loading, and we'll use lifecycle, and we're going to pass in an object, and that we'll just do state is loading, and we're going to set it to true for default. I'm actually going to do this because I don't want to screw it up too bad. Anyways, the next one we're going to make is with user data. So this is where we will hook into component did mount and fetch some data from the GitHub API. So const with and component did mount. And I'm going to set a timeout just to make it last a little longer so I can actually get to the other, to the screen while flipping screens so you can actually see it with loading. So inside of that set timeout, we're gonna, I'm using Axios, just something I'm really comfortable with, but you of course can use fetch. And we're gonna take the response and we are actually, we're gonna destruct the response a little bit. And we are going to this.set state data. Oh, we also want an is loading. Yeah, let's split this on an is loading is now false, and we will take data. Did I do that right? Oh, look at that, I did that right. All right, so let's make our components, some of the components we're going to use. We're going to use a spinner component, which is just a stateless functional component, right? And we'll just make it really simple. It'll be a div with a class name of spinner, and we'll have a span of loading. We could get more creative than that if we wanted. And we'll close this up. Okay, did I do that right? Oh, look at that, I did it right. We'll make our predicate. Remember, what is a predicate? It's a function that returns a Boolean. In this case, we already know that is loading is coming from the props, and is loading is a Boolean. And so we can just return is loading. I'm just getting rid of it as I go along. And then we'll finally make our with spinner while loading. And this is where we'll get our branch, right? And if we remember, branch takes what? Takes a predicate. So we just pass in a predicate. And see, this is why clean code is awesome, right? You can just read it really well. And then we're going to render a component. If is loading is true, what do we want to show? Our spinner. So we just pass in our spinner function. And as I mentioned before, we actually don't have to pass in the third argument. It will get implicitly passed in as our actual component that we pass as an argument to our final higher order component, right? So there's with spinner while loading. And you'll see this pattern a lot. You just call the final function enhance. In this case, we're going to compose it. And we'll compose, we'll write it from the bottom up. That's sometimes easier to like remember. Remember, compose is right to left or bottom up. And we'll do with user data. This is Recompose's compose. Recompose's compose, good question, thank you. I'm not using Lodash at all in this project. I'm only using the Recompose library, and it's on GitHub, so you can go through all my slides later, and you can make PRs for all the mistakes I made. But this uses a compose that's specifically designed to handle the higher order. That being said, I bet you if you looked at the source code for it, I doubt it's very much different than anything. Because what are higher order components? They're functions, right? So there you go. And then with loading, we need to pass in as our last one. And then I will not retype this whole thing. I mean, I could, but I won't. And we're just going to take our GitHub user and we'll clean up the white space. And we will pass this to GitHub user. Okay, so what we have, starting from the top, we have with loading, add state to our component. We have another one with user data. This is going to add our component did mount to our component. We made a spinner component. We have our predicate. It's going to tell us whether or not to show the left or the right. And then we made our branch component that takes that predicate, and we tell it what to render when it's true, and it defaults to the third one on false. And then we made our composition, which we're calling enhance, and we're wrapping our stateless functional component right here with enhance. Everyone following? All right, I'm going to save that. Prettier is going to do its thing. Made it much prettier. Who's using Prettier? Great stuff. Good stuff. All right, and we will do it live section, and please God work. Yes. So I'm just gonna do that again. Yay. So you might see like you could use this throughout your application. How many of you have like different data points that you're hitting with different components, and maybe you're firing off lots of AJAX requests, and you could do these things with what are they called, like skeletons, if you're doing stuff like profiles where you can show like grayed out fake profile skeleton or something like that. This is really useful, and you could do it with all sorts of things. I'm sure you guys are really creative and capable of coming up with some really great higher order components to use around your application. And so that is my talk on Recompose. I hope you have some familiarity with the library. There is a significant more amount of API to cover. You can see this right here. Here are the higher order components, some static property helpers, like, hey, set prop types, or set statics. Maybe use statics a bunch. You can use higher order components to accomplish this. And then there's some utilities as well. And I encourage you to take the time to go through the docs and read through them if you're going to give Recompose a try. But I do have a few resources because no one should really learn this stuff on their own. It's always best to learn from someone who really knows well. I cannot recommend highly enough Tim Kinberg's Recompose series on egghead.io. It is worth the money. It will not only explain this library really well for you, but you'll really have a better grasp of higher order components in general and how to use them in React. So Tim Kinberg, check it out. You will, if you go and check it out, you're going to see I straight up ripped some of his examples. It's all open source. It's not stealing. Um, and then you want to check out Andrew Clark. He is the author of the library. He's ACD Light on Twitter. He mostly tweets about who he likes or doesn't like on Game of Thrones, but occasionally he tweets about some good stuff. I follow this guy A Sharif. His Twitter handle is Sharif's Beat. He's from Vienna, and this guy is doing amazing things with Recompose, with functional programming in Reason and I do mean Reason in React and Reason ML. He's doing some really cool stuff. He also has a bunch of Medium articles, and if you type in one on higher order components, you're going to come up with his pretty quickly. And then going back to the functional programming, the thing that I use to kind of get into it, one of the many things is the Mostly Adequate Guide to Functional Programming by Professor Frisbee, aka Brian Lonsdorf, aka Dr. Boolean on Twitter. This guy has all sorts of like characters. I mean that like they're characters. Like Professor Frisbee is a porcupine, and he has a stop animation series on functional programming on Egghead.io that you should check out sometime. But you can download this. It's a GitHub book, so it's free. You can get these slides, like I said before, at slides.com/Kyle Shevlin/learn you recompose, right? So if you want these, you can get them later. But that is a great guide to getting into it. Even if you just read the first half, at about chapter 6, he starts talking about things like functors and monads. And I'm not going to lie, I fall asleep to that. But I'm trying to learn it, and it's a great place to start. So those are the resources I have. I'm happy to talk to you more about it afterwards. So please come up to me and ask me whatever questions you want. But thank you so much. I really appreciate it.
Take you take some questions. Questions if people have questions. Cool. And I'm gonna steal a question first and say, what about testing? What do you do for testing?
So what's great about like something like Recompose, even if you don't use this library, but you were to like start building your app with composition, is that most of the functions you're building are really small and only handle one thing. So you'll end up writing a lot of easy unit tests, right? Like I've always been confused why people complain about unit tests. Unit tests make the most sense. It's so easy to test an add function. You pass two things in and you get the result you want. That is a really easy test to write. I find integration tests and end-to-end tests significantly harder. And if you know that all the small pieces of your application work the way they do, like they're supposed to, doesn't that make the other bigger tests easier to write as well? Because you're not going to have to double up what you're trying to test. You're not going to have to double up. Hey, I need to make sure add works as well as add works in this bigger thing, right? We already know one thing works. So that's what I would say about testing, functional programming, and Recompose. Sorry.
So I wanted to say your presentation was awesome, and I agree with a lot of what you say, and I wanted to offer two things that are just kind of subtle.
Sure.
One thing a lot of people may not know is that from the React Redux project, the connect function is actually a higher order component.
I thought I mentioned that, but yeah, you're totally right. I mentioned it with multiple arguments.
Oh, cool.
Right, because it takes map state to props or map dispatch to props. It can also take what are two others? Doesn't it take context or something like that?
Another fourth argument for.
Thank you, Jason.
And the second thing I wanted to offer was if you really like functional programming concepts brought into React, another great project to look at is Reselect.
Oh, yeah.
And
yes,
like,
it is.
A lot of times you're asking complex questions of the Redux store, and it takes advantage of functional memoization.
Yeah, it does.
Cool.
So memoization, how many of you know what memoization is? Good. Memoization is not a typo for memorization. It is one thing some people don't often know about functions is that with the this keyword, functions can have properties, right? So let me set this to my JavaScript. And so let's make a named function my func. What memoization is, if a function takes an argument or a couple arguments, let's say x and a and b, what we can do is we can have this.memo or cache or whatever you want to call it. And what we can check is when we get our arguments in, we can actually say, hey, have I gotten these arguments before? If so, just return the result. It's very performant. Otherwise, save it in the memo or save it in the cache. So I'll write it nice and big so you can look up the term. Look that up. You learn that, man, you're going to pass some JavaScript interviews. I'm not kidding. So thank you. Yeah.
Any more questions before we take a break real quick?
You had a question, didn't you?
Somebody.
Sure. Personally, I don't worry about that. If they're written right, like I'm not worried about that, right? Like, but that being said, if you were to, that's essentially an integration test, right? You're seeing that the integration of all these functions ends up with the result you're expecting. So that should still be pretty easy since all these functions, except for lifecycle, are mostly pure function, right? There's some side effects in other ones that would take some extra work with testing, but other than that, it should follow the same pattern.
Oh, okay. We got more questions. You're gonna go first.
Hey, just one quick question. How much overhead is there for performance when you add this to your
Right. So the overhead I haven't found is really in performance. I mean, personally, I haven't done apps that are so like big or performance heavy that like I've hit the wall. Like I think Ryan Florence went on a big tweet storm this weekend of like 37 million renders or something like that, where he was like why do you need should component update? Like React's really fast already. That being said, I think the biggest overhead that you'll actually see and why one of the helpers in the repo is set display name is that each of these ends up being another like component nested. So if you're using the React dev tools very heavily, this can be a little confusing seeing all the higher order components composed together. So that's probably the mental overhead. The other overhead I think you would find, and I kind of made joke of this, is trying to convince a team to actually write an app this way, right? Like that's really hard to do. Like you have to sell people on doing a little bit of functional programming, and you have to sell them on using these tiny hawks all around their application. So you can see the benefit, but that's kind of hard sometimes to sell other people on. So what I was really hoping out of this talk, and I think I hope a lot of you take away from this, is like maybe you don't have to go whole hog on using Recompose, but if you just get a little better at higher order components, you might be able to use that to in your applications to dry up code or make it more testable or anything like that. Like this can be something you sprinkle in without having to use it for everything. So those are my thoughts.
And one more question.
I was just curious, how do you organize a project
Sure.
with Recompose?
Yeah. So what I have done is I just make a Hawks folder, HOCS, and most of them are named with or while or something. And so I just use it like I would use like say a helpers folder. Like so, and maybe in a utils folder or however you happen to do that, right? Like if you have these functions you pass around your app, I just treat these the same way, but I just store them in a Hawks folder, right? Because that's all a higher order component is. It's a function that you can pass around your app and use in different places. So that's how I handle that personally.